This lesson is on 2-1 solving one-step equations. The learning target is to solve one-step equations. We have 3 math terms in this lesson. Our first math term is equivalent equations, which are equations that have the same solution. Isolate, using properties of equality and inverse operations to get a variable with a coefficient of 1 alone on one side of the equation. You have often heard teachers tell you to isolate the variable when solving an equation. Inverse operation, operations that undo each other. The addition and subtraction property of equality. These properties are the properties that enable us to solve addition and subtraction equations. Addition property of equality. Adding the same number to each side of an equation produces an equivalent equation. Here's an example. X minus 3 equals 2. Well, the addition property of equality says that I can add anything to this equation as long as I add it to both sides. So x minus 3 plus 3 is okay as long as I do 2 plus 3 on the other side. I'm going to show you the same problem written in a different way that might be more familiar to you. When you go to solve equations, since it is x minus 3 equals 2, you always would add 3 to both sides. The reason that we're able to do that is because of the addition property of equality. The subtraction property of equality, subtracting the same number from each side of an equation produces an equivalent equation. It's the same idea. So here's an example. X plus 3 equals 2. So for the subtraction property of equality, I can subtract 3 from both sides, and they will still be equivalent equations. So x plus 3 minus 3, and we're going to set that equal to 2 minus 3. Again, I'll write it the way you're familiar with it. X plus 3 equals 2 was the equation. And because of the subtraction property of equality, I can subtract 3 from both sides, and I would still have an equivalent equation. Now we're going to solve equations. Our goal is to isolate the variable x in order to determine what x equals. Using the inverse operation of subtraction, we're going to subtract 13 from both sides, so we find out that x equals 14. Because of the subtraction property of equality, subtracting 13 from both sides of the equations still gives us equivalent equations. Now we will check our answer to make sure that we have the correct answer. We plug 14 in for x, and 14 plus 13. We want to make sure that it equals 27, and it does, so we know that we had the correct answer of x equals 14. Now in the second equation, our inverse operation is going to be addition. So we're going to add 3 to both sides. The reason that we add 3 and not -7 is because we're trying to isolate the variable b. Adding 3 to both sides, we end up with b equals -4. We can add 3 to both sides because of the addition property of equality. Now let's check our answer. -7 equals -4 minus 3. -4 minus 3 equals -7, so our answer checks and we have the correct answer. Now we'll look at the multiplication and division property of equality. The multiplication property of equality, multiplying each side of an equation by the same non-zero number produces an equivalent equation. Here's an example. The equation is x divided by 3 equals 2. If I multiply x divided by 3 by the whole number 3, and I multiply 2 by 3, I still have equivalent equations. The division property of equality, dividing each side of an equation by the same non-zero number, produces an equivalent equation. Here's an example. 5x equals 20. If I divide both sides of the equation by the number 5, I still have equivalent equations. Now we will solve some more equations. 10 equals 15x. 15x is multiplication, so the inverse operation is division. So we want to undo the operation by isolating the variable, dividing both sides by 15. We can divide both sides by 15 without changing the expression because of the division property of equality. Now we know that x equals 10/15. We can look at 10/15 and know that it can be simplified, so we actually end up with x equals 2/3. We can check our answer by plugging it in. 10 equals 15 times 2/3. Okay, multiplication, we just multiply across. We get 30 over 3. And both sides will equal 10. So we know that our answer was correct. This next equation is x divided by 4 equals -9. So the inverse operation would be multiplication. So we're going to multiply both sides by the denominator 4. So we end up with 4x over 4 equals -36. We still have equivalent equations because of the multiplication property of equality. Now 4 divided by 4 is 1, so we have our answer, x equals -36. Just like all of the other problems, we can check our work by plugging our answer in for x in the beginning. -36 divided by 4 equals -9, and both sides equal -9, so that is the correct answer. Solving an equation using reciprocals. 4/5 times m equals 28. Typically, since it's multiplication, the inverse operation would be division. But if you remember, when you divide fractions, you're actually multiplying by the reciprocal. So in order to solve this problem, we would take 4/5 m equals 28 and multiply both sides by 5/4, which is the reciprocal of 4/5. We're using the multiplication property of equality, so we're not changing the value of the equations. So we multiply 5 times 4 is 20. 4 times 5 is 20. M. Now we could put 28 over 1. Now you could think about it making this easier by simplifying diagonally, if you remember how to do this. 28 and 4 are both divisible by 4. So 4 divided by 4 is 1. 28 divided by 4 is 7. So you could then multiply across and have 7 times 5 is 35 over 1, which would simplify into giving us m equals 35. If you did not remember the cross simplifying, you could do 28 times 5, put that over 1 times 4, and simplify the fraction to get 35. Now we will check our answer. 4/5 times 35 equals 28. Now we could put 35 over 1, and we can use that method that I just showed you. 5 and 35 both divide by 5. 5 divided by 5 is 1. 35 divided by 5 is 7. Multiplying across, 4 times 7 is 28. 1 times 1 is 1. So both sides equal 28, and our answer is correct. Using a one-step equation as a model. Toucans and blue and yellow macaws are both tropical birds. The length of an average toucan is about 2/3 the length of an average blue and yellow macaw. Toucans are about 24 inches long. What is the length of an average blue and yellow macaw? So we're going to write step by step what we were given. So starting with the first sentence, it really didn't give us any information to solving the problem. It just told us about the birds. The second sentence tells us that the length of an average toucan is, which means equals, about 2/3 the length of a macaw. The second sentence tells us that the length of the toucan is 24 inches. The third sentence tells us what we're looking for, which is the length of the macaw. And since that's what we're looking for, we'll call that our variable L. And when we use L as a variable, we always use the lowercase cursive so it doesn't look like the number 1. Now if we look at what we were given, the first sentence looks like a formula, and the next two pieces of information looks like the information that we're going to plug in. So we know the length of the toucan, so that's 24, equals 2/3 the length of the macaw. So now we have an equation we can solve. Now this equation is multiplication, so you would typically use division, but when we divide fractions, we multiply by the reciprocal. So that's what we're going to do here. We're going to multiply both sides by the reciprocal, 3/2. So on the right side, we end up with 6/6L. And on the left side, we could do the cross simplifying that I showed you earlier. This divides by 2 and gives me 1. This divides by 2 and gives me 12. And we end up with 36. So 36 equals L. Okay, and since we're talking about a measurement, the length of the macaw, L, is actually 36 inches. Now it is your turn to solve these 6 problems. As you solve each problem, think about which property of equality you are using. We will go over these tomorrow in class. Have a great night. See you tomorrow.